Applications of solving right triangles. The first example we have are problems dealing with angle of elevation or angle of depression. Imagine looking straight ahead. The horizontal is your line of sight. Now look up. The angle formed between where you're looking and the horizontal is called the angle of elevation. If instead you look down, the angle formed between where you're looking and the horizontal is called the angle of depression. Let's look at an example. So we've got this cliff 150 feet high. We've got this person up on the top. The person is looking down at this boat in the water. We're given the angle of depression, and we want to know how far the boat is from the base of the cliff. Maybe I'll call that x. Now, here's the thing. This is why those definitions are so important. Where do I put the 25.4 degrees? Well, the angle of depression means the angle between the person's horizontal line of sight and where they are looking down. So the 25.4 goes right here. What I might find helpful to do then is to use this right triangle. Obviously, this is also 150 feet over here, and this x is the same x that I'm trying to find down at the bottom. Now that I have a right triangle, I can use a trig function to help me determine x. Which trig function links up this angle, the opposite leg, and the adjacent leg? Well, it would be the tangent function. I would write tangent of 25.4 degrees is equal to opposite 150 over x. Do some algebra and I'll have my answer. Looks like we've got to clear the fractions and then divide both sides by tangent 25.4, and then I just need to go to the calculator to figure out my answer. So we'll type that in. 150 over tangent 25.4. I'm in degree mode. And here's my answer, 315.9 approximately. X is about 315.9 feet. Another way we could have done this is to use a little bit of geometry. From geometry, this angle and this angle must be the same since this is parallel to this. It's called alternate interior angles, so I could have just realized that this angle is also 25.4 degrees and simply worked with the original triangle that I had drawn. Keep in mind that some of these problems, they may tell you the two sides and ask you to figure out the angle. Well, then you would use an inverse trig function. The second type of application we'll look at is a surveying problem. This is a little bit trickier. It's a simple question. What if I had a tall object, like a mountain, and I wanted to figure out how tall that object is? How can I use what we've learned to do that? It is a good question. I mean, here's a simple picture. The height that we're trying to figure out would be this height right here. Maybe I'll call that h. And I just don't really have any easy way to get to it. I can't get into the middle of the mountain to try to figure anything out. Well, what can I do? What I could do is I could stand some distance away from the mountain. I could look up to the top of the mountain, and I could determine my angle of elevation. Let's say that it came out to be 42 degrees. There are instruments that can be used to measure that angle. And then let's say I walked some distance away, maybe 100 feet from the first spot, and I looked up at the top of the mountain again, and I figured out my new angle of elevation. Let's say it was 34 degrees. Just using that information, we can figure out how tall this mountain is. Let's take a look. I need to find some right triangles. Well, one right triangle I see is right here. It's got the 42 degree angle in it. It's got the h. It also has a distance I don't know down here and don't really have an easy way to figure out. I'm going to call the distance from where I stood the first time to kind of the center of the mountain x. Well, if I do that, I can write a relationship for those items. It looks like the tangent function links them all up. Tangent of 42 degrees would be equal to the opposite over the adjacent. Do you see, though, that there's another right triangle in this picture? It's this one. Here, here, and here. Let's write a relationship for that right triangle. I would have tangent of 34 degrees. Let's see, what's the opposite in that blue triangle? The opposite would still be h. The adjacent would be this side right here. How long is that? Well, it's the x plus 100 more. It would be the total length of this side, so x plus 100. Notice what I've done here. I've created what we like to call in math a system of equations. There are two equations with two unknowns. If I solve the system, I can figure out the height of the mountain. I think the first thing I would do is clear the fractions. This one I would have to multiply both sides by x. This one I'd have to multiply both sides by x plus 100. I get x times tangent 42 equals h. And I get x plus 100 times tangent 34 degrees equals h. Remember that tangent 42 degrees, tangent 34 degrees, those are just ratios, decimal numbers I could get off the calculator. I just don't want to get them yet because I don't want to have any rounding in the middle. Well, from algebra, I'll now use the method of substitution. If each of these things is equal to h, then I can simply take this and substitute it in for h in this equation. Now we've eliminated the h, and we can solve for x. Let's see, it looks like I should distribute over here on the right side of the equation, so let's do that. So the right side becomes x times tangent 34 degrees plus 100 times tangent 34 degrees. If I want to solve for x, I better get all the terms that have x on the left-hand side. So I need to subtract this term and move it over to the left. And that will give me x times tangent 42 degrees minus x times tangent 34 degrees equals 100 times tangent 34 degrees. We're almost there. I need to use a trick now. I'm going to factor that x out of the left-hand side. That's kind of like reversing the distributive property. And then to get x by itself, all I have to do is divide both sides by that parentheses tan 42 minus tan 34. Well, that's it. Here's the value of x. You say, wait, that's the value of x. That's not what I wanted to know. I wanted to know how high this mountain is. Well, that's okay, because if we can figure out what x is, we'll know our answer. We've already figured out that h is equal to x times the tangent of 42 degrees. I think we're ready to go to the calculator. Now, we do have to be careful typing this in. I had 100 tan 34 on the top, and then divided by, and now the bottom has two terms in it. Since the calculator forces me to type sideways, I'm going to have to use a parentheses here to communicate to the calculator that all of that stuff belongs on the bottom. So the tan 42 minus the tan 34. Don't forget to close both the tangent parentheses as well as the parentheses I started for the denominator. There's the value of x, 298.59, etc. Well, that's not really what I was interested in, right? I wanted to know the height of the mountain, and we said that if you just take that answer and multiply it, so I'm saying take that last answer. Notice I haven't rounded anything. I'm keeping it just the way the calculator gave it to me. Take that last answer and multiply it by tangent 42. Well, there's the value of h, 268.9 approximately. So here's our answer, 268.9 feet, which I think means we have a little bit more of a hill than a mountain. Thanks for watching.